So it's similar to the one that we did before. It doesn't have that strange variable with the reset in. It has just a regular variable, which somehow it just seems easier to deal with. But we're going to use the same sort of technique to draw our circuit. So it's a little bit different here because it says parameter n equals 3. So when we look at Q, when we did it last time, it was Q2 colon 0. Here it's Q is n minus 1 colon 0, but n is 3. So this is just like last time, it is 2, 0. So this is the same as 2, 0. And what that means is that we're going to have a Q0, a Q1, and a Q2. We also have something called out bit and in bit, and we have this K. So we've got a for loop, so that makes this a little bit different. So we'll see how it works. So this one, we do have an if, so we know we're going to have some multiplexers. So we already know we're going to have 3 flip-flops. And we'll call them 2, 1, 0. And each one is going to have a multiplexer, with the multiplexer output going to the flip-flop. That's how these work. And the multiplexers have a 0 and a 1 and an S. And the S is what determines what they're going to get. And if we look at our code, we see that our if has to do with R. So R is going to be the thing that is going to be the input to tell us which part of the multiplexer we're going to take. So we're going to have a variable R, and it looks like that. Now we're going to look at this for loop, and it's going to tell us how many times we're going to do something. It says k equals 1, k less than n. So we're going to start with k equals 1, and then we count up k equals 2. N was 3. So we're not going to go any higher, because once we get to 3, then we're no longer less than n. So we're only going to do these 2 steps for k equals 1 and k equals 2. So yep. K equals 1. Okay, and it says if R so this means if R is 1, that means we're going to put whatever we're saying here into the 1 part of the multiplexer. So when R is 1, QK, let's start with K equals 1, so we'll do that one first. Q1 becomes T and Q. K is 1, so 1 minus 1 is 0. So Q1 becomes T and Q0. Okay, so Q1 becomes, I don't have my variable T yet, so I'll make a variable T. I'll put it up here. This is Q0. This is Q1. This is Q2. So Q1 becomes T and Q0. So I'll have an and. And I have the T going into the and I have Q0 going into the and that's going into the 1 because it said if R, so if R is 1. Now, we took care of K equals 1, now we'll do K equals 2. If K equals 2, then Q of 2 becomes Q of 2 minus 1, Q of 1. So Q of 2 becomes Q of 1, so I'll take Q1 and I'll put it into the 1 right there. Else, oh wait, I messed up. That was the else. That was the else. So this is, we'll come back to that one. I need to do this line again for Q2. So Q2 becomes T and, I can't draw an and, Q1. So here's T, here's my and, here's my Q1, and that goes into the 1. Now what's going into the 0 is the else part. So the else part is going into the 0. So Q2 becomes Q1, and that's going into the 0. So Q2 becomes Q1. And Q1 becomes Q0. And now we're done with the for loop, and Q0 becomes in bit. And notice I never actually used this multiplexer. Turns out we didn't need it. So I can take it out. And in bit is going to Q0, so I just have another variable called in bit. And then I have out bit equals Qn minus 1. So n was 3, n minus 1 is 2, so out bit equals Q2, and I'll call that out bit. I don't think I have a prettier one of this to show you. I don't think I saved the solutions for this homework.